Hello, my name is Mohammad Faiz Khan. I'm a physics student and a teacher. I've been teaching for past 8 years to students from JEE Mains and Advanced NEET, BSc and BTech students. The teaching is not only my passion, but it runs in my bloodline because my mother was a teacher and a principal, and my grandmother was also a teacher and a principal. So today I'm going to teach you a very important and a very easy topic, um, which is called logic gates. So let me share my screen and then we'll start. Yes, so hopefully my screen is visible. Now, so today's topic is what we are going to study is logic gates. So logic gates is a very important part for JEE Mains and advanced and most of the competitive exams. So what are logic gates? Logic gates are basically, what are gates? What do you mean by gate? Gate is something which allows something to enter or exit, right? Similarly, in binary codes, gate is something which allows or manipulates some values. Let me explain it in a brief manner, okay? So in binary, first of all, we have zeros and ones. We operate with zeros and ones, right? Okay. So in binary, we operate with zeros and ones. So we have to, calculate using zeros and ones. So we use gates for that. So first gate which we have is called OR gate. Sorry, not gate. First gate which we have, we called not gate. So from name, we can interpret that not means something which inverts something, right? So that is very true. It inverts. Okay. So what we are going to see, I'll just give you an overview about gate. First, we are going to see what does it does. What is the use of that gate? What is the diagram of that gate? And the truth table of that gate. These are the three things which we are going to see for each and every gate. Okay, first gate is not gate. What is the use of this not gate? The use of this not gate is it inverts the value. Sir, how does it inverts the value? It's pretty simple. If you give 0 to that gate, it will invert and give it back to you as 1. If you give 1, it will invert back and give to you 0. As simple as that, right? Since binary code only works for zero, since binary has only 0 and 1, so these are the only input values I can give, right? Now, what is the diagram? What does the diagram look like? The diagram for NOT gate looks something like this: a triangle and a circle in front. And if we use this with other gates, we just draw a circle. So hopefully this is clear, right? Now, what is truth table? Truth table basically tells us it is a table in which we construct the inputs and outputs. Okay, so how many inputs can you see in this table? I can see only one input. Input can come from here and output also one, right? So this, for truth table, we have only one input and one output. So input, what we can give? First, we can give it as 0. So what will the gate do? It will invert and make it as 1. Second, what we can do? We can give the input as 1. It will invert and give us 0. As simple as that. Now, what is the next gate? Next gate, what we are going to discuss is AND gate. What is AND gate? First of all, what is the use of AND gate? AND gate just multiplies. Okay, just remember AND gate multiplies. All right. Second, what we are going to see? We are going to see its diagram. So what is the diagram? How does the AND gate look like? It looks something like this. Now, when I was a student, I used to get confused with AND gate and the other gate after this, which we are going to study, which is OR gate. Now, AND gate, since it has a D at the last, you can remember the gate looks something like D. As simple as that. Okay. This is how I used to remember. Now, it has two inputs. I can see it has two inputs. Let us label them as A and B, and the output let us label as Y, because books use this notation. Okay. Now, we saw the diagram. what is the truth table going to look like? Since I told you what is y, the output, and how do we get the output? We multiply the input. So a dot b or a into b, right? So what is the truth table going to look like? It is going to look something like this. Let me just. So since there are two inputs this time, A and B, and one output, so what can be the input? First, for A, I can put 0, and B also I can put 0. So 0 into 0 is 0, right? For A, I can put 0. For B, I can put 1. I'm just taking all the possible combinations. So 0 into 1 is again 0. For A, I can put 1. For B, I can put 0. So 1 into 0 is again 0. For A, 1. For B, 1. 1 into 1 is 1. Now, I'm going to tell you an important thing, okay? Two important things. First, how to remember this possible combination. It is very easy. I'll just erase it and I'll teach you how to remember that, okay? The order is something like this: 0, 0, 1, 1, 0, 1, 0, 1. First, 0 should be together and 1 should be together, then 0 and 1 alternating. As simple as that. You can remember this, right? Yeah. And the other important thing is, as you can see, um, all the output values are given as zeros, right? Except for one output value, which is 1. So we say this one is an unique value. So if I say what is the input for unique value of AND gate, the inputs are 1 and 1. Hopefully this is clear. For unique value, what are the inputs for AND gate? 1 and 1, right? Because we are getting a unique value. Every time we are getting 0, but only in one case we are getting 1. That's why we are naming it as unique value. So to get the unique value in AND gate, what we have to substitute the input values 1 and 1. Hopefully this is clear. The two important things are clear, right? Now, moving on to the next gate, which is OR gate. OR gate. Now, first, what is the use of OR gate? It adds up. Okay, it adds up. Second, what is the diagram look like? It looks something like this. A stylish version of AND gate, we can say, right? Okay. If the inputs are A and B, what will be the output look like? Y, it will be A plus B, right? Now, what is the truth table look like? Since there are two inputs, A, B, and Y, how did I taught you to write down the values, possible combinations? 0, 0, 1, 1, 0, 1, 0, 1. As simple as that. Now, what will be the output? 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 in binary is also 1. It is not 2. Just remember that. Okay. So which one is the unique value? Can you tell me? The unique value is 0, right? 0 is the unique value. And what are the corresponding inputs to give this unique value? Those are zeros and zeros. Unique value. Hopefully this is clear, right? So what are the functions of gate? What is the diagram and what is the truth table? Hopefully you're familiar with. So let us take a question. Let us take a question so that you can solve it and give me the answer. So this is the question. Here the values are 0, 0, 1, 0, and you have to give me the value of output, right? So let me solve it for you. 0, 0. Which gate is this? I'll write it down here. This is AND gate, right? Sorry, not AND gate. This is OR gate. How did I remember that? AND gate has a D in the last. So D, this one is AND gate. And other than AND, other is OR gate, right? AND gate multiplies and OR gate adds. Do you remember that? So 0 plus 0, the output for this function will be 0. 1 plus 0 will be 1. So here input for this gate will be 1 and input for this gate will be 0. Now it multiplies, right? So 0 into 1 is 0. The answer is 0. Hopefully this was clear. The question was clear to you all, right? Now, let's move on to other gates. Now, I told you about gates, right? Now, I'll tell you the classification of gates. There are some fundamental gates. Sir, what are fundamental gates which we studied just now? Those were NOT gate, AND gate, and OR gate. Other is combination of gates, okay? Combined gates. I'll just give you the names which are NOR and NAND gate. Okay. The other one are exclusive gates. Exclusive gates, which are the names are XOR and XNOR gate. Right? Now, we have studied these three, NOT, and OR. NOR and NAND are very easy and very simple. What do you think from the name they represent? Very simple. NOR is the combination of NOT and OR. If you combine NOT and OR, you'll get a NOR gate. And if you combine NOT and NOT and, you'll get a NAND gate. As simple as that. Let us start with NAND gate. Okay. Let us start with NAND gate. So what is its uses? Its uses is basically, it's a combination of gates and it simplifies the circuit. It simplifies the circuit. How does it simplifies the circuit? We'll discuss it further in the lecture. Okay. Simplifies the circuit. Now, NAND gate, it simplifies the circuit. What is the diagram? What does the diagram look like? I told you it is the combination of and has a D in it. So D and I told you NOT gate. For if you are using it with other gates, then you have to just draw a dot circle. So two input A, B and NOT. So output will be A dot B and bar. This bar represents NOT. Okay. For example, if I'm writing 0 bar, that means 0 invert 0, that is 1. If I'm writing 1 bar, that means invert the 1, that is 0. Hopefully this is clear. What does the bar represent, right? Now, what is the truth table? What does the truth table for this gate look like? A, B, and the output Y. So what is the sequence I taught you? 0, 0, 1, 1, 0, 1, 0, 1. Now, first you have to multiply and invert the value, right? Multiply these two. 0 into 0 is 0. And then invert the 0, you'll get 1. 0 into 1 is 0, invert it, 1. 1 into 0 is 0, invert it, 1. 1 into 1 is 1, invert the 1, you'll get 0. So now you can tell me which one is the unique value, this 0, right? What is the corresponding input for this unique value? That are 1 and 1. This is the unique value. Hopefully this is clear. Now moving on to the NOR gate. NOR gate, again, the uses are, it is a combined gate. It simplifies the circuit. Okay. What is the diagram look like? What does the diagram look like? It's pretty simple. A OR gate with a dot, right? NOR gate. A, B. What does an OR gate do? A plus B and just a bar in above, right? Now, moving on. Let us draw a truth table related to that. What does the truth table look like? The truth table will look something like this. A, B, Y, 0, 0, 1, 1, 0, 1, 0, 1. First add them and then invert them. 0 plus 0 is 0, inverted 1. 0 plus 1 is 1, inverted 0. 1 plus 0 is 0. 1 plus 0 is 1, invert 0. 1 plus 1 is again 1 for binary and inverted 0. So which one is the unique value? I can see this one is the unique value, right? This one is the unique value. Hopefully these gates are clear. Now, if you see some question like this, you can solve it on your own. So thank you for listening. Have a good day.